We're here just north of Golden at Denver Water's Ralston Reservoir, and we're giving a tour to hydroelectric professionals from all over the country and international community of a new hydrokinetic installation that we have installed at this site. We're standing right on the banks of the South Boulder Canal, which brings water from Gross Reservoir, which is about 8 miles upstream of here. At this site, we currently have 4 turbines and generators installed. And today we're celebrating the grid interconnection of these hydrokinetic units that are here behind us. We are working with a company called Emrgy, just got everything installed and up and running in the last few days.
It's unique compared to conventional hydroelectric installations, which typically require the construction of a dam. These systems can be placed simply into a channel where there's flowing water, and using the natural energy within that water, it can produce hydroelectric energy. As water flows through the turbines, it activates a spinning rotor that, as it rotates around the shaft, generates torque and speed. That torque and speed is converted into electrical power at the generator and fed into a power conversion system on shore.
I work a lot with wind turbines, and it actually reminds me a lot of it's really like a vertical wind turbine.
In 2017, we partnered with Emrgy and the United States Bureau of Reclamation on a project to pilot this type of hydrokinetic generation. So this really is the next step in that project.
The technology you see today represents the newest generation of our equipment. A lot of the learnings that we had out here before, we've now reflected into equipment that's easier to lift, easier to install, more plug and play with the existing utilities.
And this canal has been here since the 1930s, and it had never really been contemplated to use it to generate power. And now we're generating electricity using these hydrokinetic units and delivering it directly to the local utility.
These turbines can instantaneously generate anywhere between 5 kilowatts and 25 kilowatts each per rotating turbine based on the speed of the water and the depth of the water. That can represent tens of thousands of kilowatt hours per machine.
Denver Water's interest in hydropower is really multifaceted, and we generate power to sell back to the electrical grid, and it also helps us meet our sustainability goals of being net zero and offsetting our electrical consumption.
We're taking advantage of the energy that's right here in our backyard, and so this is a great complement to those alternative energies that are generating now on the distribution grid.
This has been a really rewarding and interesting project to work on. The alignment of our goals with outside entities like Emrgy has allowed us to move the needle and driving towards a sustainable future.